Section 4.2 out of our chapter book here is all about how microorganisms change the soil that we live with. Kind of thing we're going to kind of review a little bit is our rock cycle. Last section we talked about weathering. And if we look at weathering, you probably saw this in the last video, but we're talking with just weather, raining, causing our rocks to maybe move down the hill. Humans affected. You can see it's breaking into smaller pieces. And as they move further down the hill, oops, yeah, we can just go back here. Sedimentation, though, that's when it flows down the hill, ends up in a river. And you can see the little particles going right through there right now. And the river flows down. And it drops them off when the river speed goes slower. It drops them off into the bottom, and you can kind of see where they're just making layer upon layer upon layer. And over time, those layers get cemented together, and they end up making that rock. If they get pushed down far enough, they end up starting to get heated. When they get heated, that magma, or it turns into magma, or the magma itself takes the area and heats it, and causes that metamorphic change, that pressure and heat that pushes down on them. Then that magma, if it's moving through the ground, makes its way almost to the surface, becomes intrusive igneous rock. But if it gets all the way to the top, boom, here it goes. And you've got the extrusive igneous rocks on the side of the volcanoes and the top as well. So you just put that there. All right, so with that in mind, let's move on. I believe you saw this in the last video as well, as about how does dirt form. I know it's not super exciting, but we are looking at the dirt forming in this little animation, which we find in our ClassZone.com. If you go to ClassZone.com, you can click on the soil form visualization. And when you do that, you can kind of just follow. Oops, let me move that up there for you. So you can kind of see where you just have your basic layers of rock there. And over about 10 years, that top layer gets broken down by physical and chemical weathering, which we talked about in class. And we get a little layer of just broken pieces, not enough to grow anything. About 100 years go by, and we still have that broken layer right here in Horizon C. The rock bed is still there, but we have this little top layer of even more broken down materials. That's actually soil. Not enough to grow anything, but still beginning of soil. About 1,000 years go by. Now we start to get a little bit of plants growing, but we have this new B horizon. That's kind of our clay type soil, stuff that got washed down through the dirt, and it wasn't quite rock, but not quite dirt. About 10,000 years go by, and now we finally have soil that can grow big plants and trees, and we have a soil A, B, and C horizon. So that's pretty much how soil is formed, and I'll get rid of him for now. And let's get back to our visualization here. Move him down. Now, what actually causes the weathering of soil through organic process? Time. Just needs time to go through. Animals and organisms that live in the area, they eat, they die, they do their business, it becomes part of the soil. The type of rock in that area. What kind of rock? Is it a hard rock? Is it a soft rock? Can it break down a lot faster? Landforms, mountains and valleys, allows water to rush down, taking sediments with it. So down at the bottom of hills and mountains, now we're looking at areas that are collecting a lot of sediments, allowing it to turn eventually into dirt. the climate's area. We'll talk about how that happens. If it's a hot and dry, there's going to be less decomposition. If there's wet, then it's going to be more. Plant cover. If there's plenty of plants in the area, you're going to get lots of plants that die. They die in that area, they become part of the soil. The organic material, that humus, that's the key word, humus, that are part of the soil. Now, when we start looking at horizons, here's just some examples. You have horizon A, which is right up here on the top. That's this area. That's the topsoil. That's the soil that's growing plants. Horizon B is that clay-like soil, which is the one right below it. Horizon C is some soil and rock pieces. And then the bottom one is just the rock bed. You can kind of see here. Oops. Horizon A is called topsoil. It's usually darker in color because it has all this organic living material, or parts of the things that used to live. Now they're dying and decomposing. Part A. Horizon B tends to be a little bit brownish or reddish. It's clay and minerals. It's the smaller pieces, and very little living things. Now, Horizon C, yellowish brown usually, depending on where you're at, and with rocks are in that area, but that's the deepest layer of soil. And then you have your rock bed. Now this one right here, this little animation, shows you where all the different types of soils that we have around the world. Remember, it all depends on where you are at, your area. And as soon as this comes up, you'll be able to see. We've got a map of the world, and there's all these different types of soil. All right. But it all depends on the type of rock in the area, the type of climate, what kind of animals live in that area, what kind of weathering occurs in that area. So like if you think of like volcanic rock, if you look here, maybe you see all the purplish stuff popping. That's where volcanoes are or have been. That's where we get that volcanic soil. Desert soil, you can kind of see the United States has a whole bunch. Africa has some desert, Australia. Tropical soil, that's all of these colors. And you notice those all kind of show up right around the equator, right here, real close to the equator. Temperate soil, that's kind of us. That's all these green shades and blues. You can see that's just above where the tropical soil was, but not all the way up to the top. And then we have polar soil. Obviously those are just up in the polar areas. So, but if you take in the temperate and the tropical, now that makes up most of the planet's soils. The desert soil and the volcanic soil take up a smaller area. I think I forgot one. But as you can see, that's where all the soils in the world have been. Let's go back to our lesson notes. Here's how animals end up affecting the soil. And I think I'm going to end up having to move this box a little bit so that you can actually see most of it. Plants and animals, although when the plants die, they break down and decompose into organic materials that become part of the soil. The microorganisms, that's the bacteria, the little microscopic things that you can't really see. Well, they eat all of the decaying food or the materials, and they actually produce the nutrients that the plants need to grow. So the plants grow off the nutrients from the microorganisms. Microorganisms also die in the soil, and they become part of the soil, and they become part of the nutrients. Animals like ants and termites, gophers, well, they end up, they dig their way through the soil, and they leave tunnels, which air and water can get mixed in there, and that can help mix up the soil. They also do in the soil, if you know what I'm talking about, and that also becomes part of the fertilizer within the soil. So they die underground, they become part of the food chain for the microorganisms to decompose as well. So That's how organic matter gets into the soil from the plants, from the animals, and so forth. Um, and soil itself has four main properties. Um, Texture, that was the phone ringing, because they didn't want to talk to me. Texture, which is basically just the size of the particles. The three main categories: sand, silt, and clay. Well, sand, the particles are the biggest. Silt, the particles are just a little bit smaller, and clay, they're the really smallest. So when those really small particles get together, like clay, that becomes that B horizon. That's why it's really hard for water to drain through clay, because there's very little space between those. Color, if it's darker, it lets you know that it's organic. If it's lighter, it's not so much organic. Color also tells you if it drains well or not. Pore space, that's how much air is in between the particles. More pore space, water can drain through it. Less pore space, water can't drain through it. And then the chemistry, like what is the acid level? What's the pH of the soil? 7 is a neutral soil. Acid soil is more towards a 14, and a basic soil is more towards 0. If you look at like pine needles, for example, near pine trees, that tends to be a little bit more acidic. So some plants need that to grow, so other plants need basic soil to grow, some just need neutral soil. So I think that's about it. Well, no, here's a chart about, and I'm not going to read through this for you, but I'll kind of slow down. And if you want to slow down and read through, it's kind of a flow chart that tells you what kind of soil we have. We are going to end up doing a lab with this information. So I'm going to have you bring in a bag of dirt from your house, around your house, and we're going to try to test it. So if you could make sure that you bring in a little baggie of soil after you watch this the next day, we can try to get this lab taken care of, because we'll follow through these steps. And so there we are. I think we're done. I don't know if you can actually tell, but throughout the whole time I've been getting interrupted. It should be an interesting thing to see what happens. Yeah, and then we're into the next section, so stay tuned for the next one. So talk to you later.